All right, guys, let's go ahead and get started with our day. So today we're going to be talking some more about solving equations. Today's going to be a longer class where you're going to have about 20 minutes after our whole group instruction and guided practice to do some of your independent practice. And I'm going to have some certain students who I'm going to ask to stay back with me to complete some small group assignments, just to help fill in some gaps. So let me go ahead and share my screen with you. Make sure you have your math notebook, your pencil, and your calculator ready to go. We're going to start talking today about solving one-step equations. Solving one-step equations. We'll want to remember that we want to annotate, that means to find and highlight important information that's going to help us to solve equations. So of course, I've never left you alone. I'm going to model my thinking with you today. We're going to work on a lot of guided practice examples today, and we're going to make sure that you are built with fireproof material so that you are prepared for your independent practice and your test. I wanted to make sure everyone knew this. Your test has been moved from Monday. Your test will no longer be on Monday, and I'm moving it to next Thursday, okay? I'm moving it from Monday. You'll no longer have your test on Monday. We'll have a regular live session on Monday. And on Thursday of next week, you'll have your test, okay? So on that Thursday, we won't have a live session. You'll have your test that you're able to work on all day. So let's get to work. Our learning objective today is to be solving correctly one-step equations. So I want us to first write in our notes. Go ahead and write this, please. And I want you to write these 3 examples as well. Skip about 5 lines between each one of these examples. Today, when we're solving one-step equations, I have to make sure you're able to solve using fractions and decimals. And so that's where we're going to start today. I'm recording this lesson. So if your computer goes out or it glitches or anything like that, or if you just need to watch this again to help you to prepare for your test next Thursday, it will be available to you, okay? So we're going to be solving one-step equations today using fractions and decimals. I want to give you a little bit of time to make sure you have written down all 3 of these examples, skipping 5 lines between each. So let's look at number 1. Let's look at number 1. Can someone please turn on their mic and tell me, where is our variable in number 1? What's our variable?
The P.
Very good, our P. So what we're really being asked here is 9.4 plus P equals, and I want to change that from 4.8 to, let's make that 14.8. Let's make that 14.8. Because then we'd have to mess with negative numbers, and I don't want us doing that yet.
P equals 8.4.
P equals 8.4?
Yeah.
Let's see how
5.4.
Let's see how we do. Let's see how we do with that. The first thing we'll need to do here is we want to isolate our variable, or in other words, get our variable by itself. So if 9.4 is being added here, we must subtract 9.4 to get our P alone. We want to remember whatever we do on the left side of our equation, we also have to do on the right side of our equation. So let's see if our P was correct. With your calculators, please put in 14.8 minus 9.4. What's our difference?
I got 5.4.
Okay. So P is 5.4. So in other words, if I wanted to substitute that back in to check my work, I would just replace 5.4 with P, and my sum here should be 14.8. Pretty simple with this one because we're just doing adding and subtracting. We just added a decimal in. Numbers 2 and 3 are going to be a bit more difficult, and so I want to give you some time. Let's look here at number 2. Hopefully you've written this down. It says y over 5 is equal to 2/5. Y over 5 is equal to 2/5. Now, I don't want you to work too hard with this one. What number has to go here in order for this fraction to be equal to 2/5? Don't think about it too hard. It's not a trick question. What number has to go here in order to be equal to 2/5?
2.
2. So y is 2. Number 3, here we have 8. Oh, what's happening here between 8 and S? What's happening here? Are they being added together, subtracted, multiplied, or divided?
Multiplied.
Yeah. So to help my life out, I'm going to put this over 1. I want us to always know any whole number. If we wanted to write that whole number as a fraction, we would just put it over 1. 1 would be our denominator. Remember, our goal here is to get that S by itself. So what we have to do here is multiply by the reciprocal of this. Remember, we're just going to flip our fraction. So if I'm multiplying the reciprocal, what would that fraction be? I'm just flipping 8 over 1. Flip 8 over 1. It's going to be 1/8. Okay? So now these will cancel out. These two numbers will cancel out. And now I have my S alone, but I'm not done yet. Remember, whatever I do on the left side, I have to do on the right side as well. So if I multiplied by 1/8 on the left side, I have to multiply by 1/8 on the right side. Okay? And so my answer here, remember we're multiplying fractions, we just go straight across. 1, and what is 2 times 8?
16.
16. 1/16 is what S is. Okay? We're going to get some more practice with fractions and decimals on Monday as well. That's the reason why I pushed that test back. I felt like we were learning a lot of heavy stuff, and we're going to learn about inequalities next week. And so I wanted us to have more time to practice, get good at it, build that math muscle so that we could be successful for our test on Thursday. Okay? So let's keep going. We're now going to look at, let me let some kids in, guys, excuse me. Emily, I'm sorry you can't see, sweetie. It's just I don't know what to tell you, sweetie. Just know I'm recording the lesson.
Okay.
Isaiah, please don't comment in the chat unless Miss Neville asks you to. Okay, so let's look at our guided practice here. Hopefully everyone can see my screen now. If not, I'm recording the lesson. So our guided practice here, please write down this example, and we want to call it example 1. This is example 1. Please take some time to write this down, because together today we're going to annotate. That means find and highlight the important information we need to solve our equation. So please write this down now. You've got 2 minutes. Okay, so let's keep going here. Example 1. Okay, so the sum, ooh, that's an important word. We need to highlight it. Remember from our Monday lesson, when I see that word sum, what operation will I be using?
Addition.
Addition, very good. So the sum of Ryan's age and Renee's age is 35. I'm going to highlight this too, guys. Is 35. Is 35. You see how I did that? They told me where my equal sign was going to be. Whenever I see that word is, that usually means that's going to be where my equal sign goes. Something we'll want to remember. If Ryan is 16, that's going to be an important age, important number. How old is Renee? Now, do I already know what operation I'll be using?
Addition.
Yeah. So 16, and they're telling me to use X for Renee's missing age. So we want to write that down on the side. X equals Renee's age. Everything Miss Neville's doing, you want to do as well, so that we can be successful when we do it on our own. Okay? So 16 plus Renee's age, Ryan's age plus Renee's age equals 35. So I have to isolate my variable. So if 16 is being added here, what's the opposite of addition?
Subtraction.
Very good. So I'm going to subtract 16. When I do, I now have my X alone. Whoop, whoop. Now, whatever I do on my left side, I also have to do on my right side. So if I subtracted 16 on my left side, I need to subtract 16 from my right side as well. Use your calculators, please. What is 35 minus 16?
$19.
Okay, so X is 19. Renee is 19 years old. Take some time to finish your answer. Write it down. We're about to move on to our second example. And I promise they won't all be this easy. They're going to get a little bit tougher. So you want to stay with Miss Neville as I'm modeling our thinking. All right, so let's go on to our next example. Example 2. We don't have to write this one down, guys. All I need you to write is example 2 here. And please draw a triangle. Please draw a triangle, just like the one we see in our picture. Okay, actually did pretty good. Good job, Miss Neville. On one side of our triangle, we want to write 280 feet. On the base of our triangle, we want to write 300 feet. And on the other side of our triangle, we want to write X feet. Take some time to get that done. So when we look here, we're going to annotate our text. When we look here, it says the triangular shaped walking path in the park shown has a perimeter of 990 feet. Remember, perimeter is the addition, us adding the sum of all sides of a shape. So write an equation to find the length of the side of the path represented by X. So we know our is 990 feet. Yes, all of the lengths of this triangle have to add up to a total of 990. So I kind of already gave you the answer about what operation we'll be using. Will we be adding, subtracting, multiplying, or dividing? Remember, perimeter is the sum of all sides of a shape.
Adding.
Very good. So, something plus X. But only one number can go here. So what must I do with 280 and 300?
Add them together.
Add them together. And when I add the length of both of those sides of that walking trail together, 580. So this is my equation. 580 plus X equals 990. Please, I'm not going to hold your hand now. You got it. Now, I want you to find, don't tell them the answer out loud because I want everyone to have time to work. Now, I'd like you to solve this equation. Remember, we want to isolate our variable first. We want to isolate our variable first. And then we're going to solve. Okay, so someone don't give me the answer. Someone unmute themselves and walk me through what's the first step we have to do here to find the value of x. Remember, we want to isolate our x. So if 580 is being added here, what's the opposite of addition?
Subtraction.
So if I added 580 here to get my x by itself, to get it isolated, I have to subtract 580. Then I want to make sure whatever I do on my left side, I subtracted 580. I have to subtract 580 from my right side. So use your calculators. What is 990 subtracted minus 580? What is 900? Go ahead.
410.
410 feet. We want to make sure we put the unit of measure there to make our answer complete. Okay, so let's keep it moving. Our last practice with word problems where we have to write out our equation and solve it. Example 3, please write this one down. I'll give you some time. Isaac received, remember we're going to annotate today. Isaac received $125 for his birthday. He spent $65 on a new video game. How much money does Isaac have left? And we want X to equal money left. So
Miss
you had
Neville.
an all. Go ahead, sorry.
You should post the videos with the classwork for that day.
I do, sweetie.
Okay.
So 125 minus 65 equals X. Remember, he had $125 in the beginning. He spent $65 of it on his new video game. And now what he has left is X. This is pretty simple. Can someone tell me, using your calculators, what is X?
60.
Very good. And I actually want to make sure I write this correctly, $60. Okay. So our last part of our notes today, before we break down, and all of you will be working on some different assignments based on your work. We're going to be looking at identifying patterns to write equations. Please write this as your heading in your notes. Guys, give me 1 second. I'm going to let a kid in. Or 2 kids. Is everyone else able to find the videos where I put them in? I'll go over that today where they are.
I know where to find them.
Yeah, me too.
Okay. So they should be in the folder where you're doing your homework or your homework. You should be able to watch our live lesson there. Okay. So let's keep it moving. We're looking at identifying patterns today. You don't need to write this one down. You don't need to write this one down. So Karen ran a certain amount of miles each week, and we're going to let miles stand for M. Notice I'm underlining that. And each week, we're going to let that be represented by W. What is the relationship between the miles Karen ran and the weeks she ran them? So what we're asking here is for you to identify the pattern. As the weeks increase, 1, 2, 3, 4, 5, what happens with the amount of miles she runs? What's the pattern there? In other words, how did I get from 1 to 6? I want to make sure we know something. We're looking at the relationship here. I'm going to write W and M here. We're looking at the relationship here between these two numbers, okay? The numbers in these two rows. Whenever a number is getting bigger, we're going to be adding and multiplying. So you'll notice no matter how many weeks went by, the amount of miles she ran were always more than the week she ran them. So 6, for example, is bigger than 1. 8 is greater than 2. 10 is greater than 3. The question Miss Neville is asking you is, what did I have to do? What operations, what numbers did I have to add or multiply to 1 to get to 6? So we're going to have our equal sign. This is an equation. And we want to know the relationship between our miles. If I did plus 2, is that what you see here? If I added 2 to 1, would I get 6?
No, ma'am.
No. So I have to find out, how did I get from 1 to 6? Here's a hint. I had to multiply 1 by something, and I had to add something to 1. So could I have multiplied times 4? 4 times 1 is 4, and then added 2 and got to 6?
Yes.
Yes, but I have to follow this same equation for all of these. So does that work when I go to week 2? If I multiply 2 times 4, 2 times 4, what's 2 times 4, y'all?
8.
8. And then I added 2, would that equal 8?
No.
No. So I can't follow that equation necessarily. Here's the one I can follow. I have to multiply 1 times 2. Can someone tell me what that is?
2.
And then I have to add 4. Now, does that work? And that will give me 6. Will that work here? 2 times 2. What's that going to equal, guys?
4.
And then add 4. Will I get 8?
Yes.
Yeah. Let's see if it works for week 3. 3 times 2 is?
6.
Then add 4. And will I get 10?
Yes.
Yes. So when I write this as an equation, I want to say, here we go, 2W, sorry. I didn't leave enough room for myself. 2W plus 4. Now remind me, when I put a 2 or when I put a number, a coefficient beside a variable, what operation am I using?
Multiplication.
Multiplication. So 2 times the week plus 4 will equal the miles she ran. That's a pretty tough one. Take some time to finish writing that down, and we're about to go on to our last example of the day before I assign you your independent practice. Okay, so our next guided practice says Mark drove at an average of 45 miles per hour. I'm going to annotate this. I'm going to underline. The table shows the total distance he covered over time. So when he drove for 1 hour, he went 45 miles. Then when he got to the 3-hour mark, the model that you see me drawing, could you draw it as well, please? One hour, he drove 45 miles. By the time he got to 2 hours driving, he had driven 135 miles. And by the time he got to the 5-hour mark, doing all kinds of messing up today. And then by the time he got to the 5-hour mark, he had driven a total of 225 miles. So now we have to write an equation that tells us the relationship between the time and the distance. Remember, because 1, to get to 45, we had to do some adding there. Or multiplying. So let's see if this is it. Could I just multiply 1 times 45 and get 45? That works here. Would it work here? Use your calculators. In other words, is 3 times 45 135?
Yes, ma'am.
Yeah. So it works for 3 miles. Does it work for 5 miles?
Yes, ma'am, it does.
It does. So we're using 2 variables here. We're going to let T stand for his time and D stand for his distance. So I would have to multiply 45 times T to equal D. Please take some time to write that down. We're going to do a bell ringer about this again on Monday because we're just now learning these patterns. Hopefully there'll be some smaller graphs later on so that you can be a little bit more prepared and get a better hang of it. But you will see these on Thursday's test. All right, so let's talk about what you're going to be doing today. Let's talk about what you're going to be doing today. If you would, please open up another tab on your computer if you can. Sometimes with our computers, we can't open up another tab while the Teams meeting is going. And what I want you to do today